Alright, everyone, we're going to start in a couple of minutes. If anyone is, or you know what, sorry, never mind. Alright, so we'll start in a minute. Right now it's 3:31, we'll start at 3:32. I hope that you can see my work clearly. Okay, so it's 3:32. I'm going to get started. So, thank you so much, everyone, for joining me in today's 5th grade math live stream. And this is a continuation from my previous 5th grade math live stream. After this live stream, you can check that out on our channel. So the questions we're going to cover today are question number 2, question number 22, and question number 30 from the 2018 STAR Math Practice Test. So I'm going to begin with question number 2. Okay. And just to say before, if you guys have any questions or if you guys want to say something, please feel free to type it in the chat. And one last thing, please subscribe to our YouTube channel and turn on notifications. It really does help support our channel, and it encourages us to do more. So with that being said, let's start with number 2. So the first thing you should do on every STAR problem is to look at the question and highlight any key information. So, number 2, which comparison is not true? Usually STAR does a pretty good job of highlighting which keywords you have to look at in a question, but just in case they don't get into the habit of highlighting. So, which comparison is not true? So, after that, you have to ask yourself what the question is saying. The question is saying that out of these 4 answer choices, which one is not correct? And let me actually... Okay, yeah. So, which is not correct? Or which is false? I mean, I should. Okay. So let's start with F. For these kind of problems, I would recommend using a number line, or using the method of drawing a number line. So that was not the right thing. Number lines really help in these kind of problems because you see where each number is, and it helps you become more organized. So let me draw. Sorry, let me make the line a little bit lower. Let me draw it. There. And let me draw the arrows as well. So to begin with, for answer choice F, we see 3.375 and we see the number 3.275. And another way to say this, remember from our previous live stream, this symbol means greater than. So if we have a number like 6 and if we have a number 2, then we're saying 6 is greater than 2. So this is greater than, and this symbol is less than. So if we have a number, say 10 over here and number 6, we're saying 6 is less than 10, which is true. So this symbol is greater than, this symbol is less than. And actually, let me put a star next to it just to show how important this is. So greater than, less than. Okay. So we see this number 3.375 and 3.275. So we know that 3.3, let's just remove this. 3.3 and 3.2, they're both in between 3.0 and 3.5. So 3.0 and 3.5. 3.0 and 3.5. And just for this lesson's sake, let me also put the intervals. So 3.0, then we'll put 3.1, 3.2, 3.3, and 3.4. And now let's plot these numbers. And to make it easier for the viewers, we'll make the left numbers blue, and we'll make the right numbers red. So left blue, right red. So let's start by plotting 3.375. So 3.375, where would we plot that? Well, let's start with its unit number and go to the right from there, and hopefully that will help us plot the number. So 3, we know is in between 3 and 3.5. Sorry, 3, we have this, and then 3.3. 3.3 is right over here. And then we see 3.375. So it's greater than 3.3. but it's less than 3.4. So it would probably go right over here. Or not probably, it would go right here. 3.375. And then we look at the right number, 3.275. So let's use the same technique. 3.2, it's greater than, it would be right around here, 3.2. And then we see the end, 3.275. It would be greater than 3.2, but it would be less than 3.3, since it's this 10th place is not 3.3. It would be in between 3.2 and 3.3. It would be right here. So from looking at our number line, we know that number lines go from from least to greatest. And we see that red is less, since it's on the left side, it's less than blue, which is on the right side. And if we look back, in other terms, blue is greater than red. So blue is greater than red. Now let's look back at our answer choice. Did we say that blue? We said that blue was 3.375. So blue would be greater than red, or 3.375 is greater than 3.275, which we assigned as red. So since this answer choice is true, for the question's sake, it would be incorrect. So let me just use green. It would be incorrect. And now let's look at G. Let me actually go a little bit lower so that we have more room. Okay, so right there. So now we get our handy dandy ruler, and let's make it a little bit lower. And let's draw our sweet number line. And this, I said, was answer choice G. So G, we see the numbers 6.875 and 6.9. So let's try to look for a minimum and maximum value we can use for a number line. So we know 6.875 and 6.9 are greater than 6.8, which would go right here, 6.8. And we also know that 6.875 and 6.9 are less than 7, because we know from the units place, 6 is less than 7. So we can put 7 here, and for middle we can put 6.9 and 6.95. 6.95 would be in between 6.9 and 7, and 6.85. 6.85 would be in between 6.8 and 6.9. If you don't know what I'm doing, I'm just listing out my intervals, or like the numbers that would come in between the 6.8 and 7 on our number line. It just helps for clarity. You won't have to, once you know how to do the basics of like you getting 2 points and then looking at the number and plotting the points, then you won't have to use as many numbers this is just for clarification. So let's make this blue and this red. Okay. So 6.875. So according to its 10th place, that's an 8. And we know 8 is less than 9. So we know that it would be below 6.9. And we see if we go on 6.875, and over here we can rewrite 6.85 as 6.850. And we know 75, which is shown right over here, is greater than 50. So because of that, we can say 6.875 is in between 6.85 and 6.9, and it would go right over here. And then 6.9, we've already plotted that as over here. So remember the rule of number lines: least is on the left and greatest is on the right. If you don't know how to remember that, then remember least and left start with an L. That's probably the simplest way to remember, but yeah. So looking at our answer choice, we see this, before we even start with our answer choice, my apologies, let's look at our numbers. Let's look at our colors over here and see which one is greater, which one is less. So we see that red is on the right side, so this would be greater than this. Or another way to write it actually would be, if we want to use the less than symbol, we can say that blue is less than red. And we see that blue is certainly less than red. So let's look at our answer choice. Do we the number that we assigned blue, 6.875, is that less than 6.9? And yeah, this statement is true. So that means that in the terms of the answer choice, this would not be the right answer choice. So let's move on to H, and let me just also write J right here. So H, draw our number line. I'm going to try to do this as quick as possible. If you guys want me to slow down, then please type in the chat. Let me just slow down, and I will more than happily slow down for you. But as we can see, our numbers are 2.65 and 2.675. So let's assign colors. H, 2.65 is blue and 2.675 is red. So we know that this is in between 2.6 and 2.7. 2.7. And we can make 2.65 here. Oh, sorry. 2.65 right in the middle. So looking at our colors, see that 2.675, let's start with red, let's start with blue. Why do I have red? Let's start with blue, 2.65, we already have it right here. And red, 2.675. That would be, we know that 2.675, we can rewrite 2.65 as 2.650. We know that 75 is greater than 50. And if we look at the last two digits, right here and right here, we see that 75 is greater than 50. Therefore, 2.675 right here is greater than 2.50. So red is greater than blue. And we see in H, this statement is completely false. They switched the numbers. 2.675 is supposed to be greater than 2.65. It's not the other way around. So this would be the right answer choice. And since on the STAR test, you were given a lot of time, it doesn't hurt to check the next problem, check J. So let's just go on with J. So remember, ruler, black, remove ruler, 7.675 and 7.75. So we can say 7.6 and 7.8. And let's make this blue. Let's make this red. So blue, which is 7.675, is closer to 7.6. So we would plot it somewhere closer, right here. And then red, which is 7.75, is closer to 7.8 by 0.25. So it would be right over here. And we see that blue is less than red. So J would be, so this statement would be a true statement, which means by the question it would not be the right answer choice. So H would be our right answer choice. If you guys have any questions as to what I did, please put it in the chat. I'm going to move on to question number 22. Right, so let's start by highlighting our question and keywords from the question. A temperature in degrees Fahrenheit is shown in expanded notation. And you have the expanded notation right here. How is the temperature in degrees Fahrenheit written as a numeral? Okay, so before we start, let's define what a numeral and a expanded notation of a numeral is. A numeral is just like any number, 2, 31, 50, 100, those kind of numbers. Expanded notation is expanding, so let's just say 151. Expanded notation is expanding this number to show each of its place value. So 151, we can write 1 times 100. So that accounts for the hundreds place. 5 times 10. That accounts for the tens place. And 1 times 1. That accounts for the units place, or the ones place. So this would be a numeral, and this would be expanded notation. Okay. So with that in mind, let's look at this expanded notation right here. Expanded notated expression right here. So 9 times 10 plus 4 times 0.1. And we have to make it into a numeral. So what would we do? We would have to multiply whatever's in the brackets because of PEMDAS, and then we would have to add these numbers. So right here, so 9 times 10, that is equal to 90, because we write it 9 times 0 is 0, 9 times 1 is 90. Sorry, 9. So you get 90, and then you do 4 times 10, a tenth. So 0.1 times 4. And how you multiply decimals, as I've covered earlier, what you do is first you remove you convert all decimals. No, I'm so sorry. What you have to do is you have to make the decimal into a whole number. So what you would do is 0.1 times 10 is equal to 1. So after that you multiply the whole numbers together, so 4 times 1. And actually, I think it would be easier if I just put it here. So 0.1 times 10 is equal to 1. And then you would do, that's your first step. Second step, 1 times 4 equals 4. And then your third step, what you would have to do is that you would have to divide by 4. Since you multiplied by 4 right here, you would have to do 4 divided by 10, not 100, and you get 0.4. So this is equal to 0.4. So let's add 90 plus 0.4, and let me actually make some room. You would do 90, and 90 can also be written as 90.0, it's the same thing. And whenever you're adding, remember to align your decimals. So 0.4, add those, and you get 9, 0.4. And that is your answer choice. Sorry, that is your answer, 90.4. So 90.4. Okay, so if you guys have any questions, please feel free to type it in the chat. I'm going to move on to question number 30. And let me actually make a border so that we don't get confused as to what our work. Sorry, we don't get confused as to our work. We don't want. Sorry, we just don't want to be messy. That's all. So Elias has 3 containers of cooking oil. Wait, almost forgot. Highlight all the important words in your question. So Elias has 3 containers of cooking oil. The table shows the volume of cooking oil in each container. Which list shows the containers in order from least to greatest in volume in liters? So, least to greatest. And thankfully, they use the same order as a number line because the numbers on the left would be the least and the numbers on the right would be the greatest. Let me just erase that. Okay. So, now we have to see which number is the greatest and which number is the least. So, let's start. So, like we did with question number 2, what we should do, and I'm not talking about like the second question, I'm talking about question number 2, the first question I did in the live stream. So, what we should do, as always, is make a number line. Number lines, especially in this problem, can be very useful. So, number line here, number line here. So we see 0.502, we see numbers like 946 thousandths. That's the proper way to say it. You have 502 thousandths, and you have 1 and 42 hundredths. So what we see that the numbers are between 0 and 2. So maybe we can use those as our minimum and our maximum. Oh, not 0.2, sorry. We see the numbers are in between 0 and 2. And just for the sake of the problem, I'm going to use black for X. Or you know what? I don't even have to do that. What I can just do is I can use the letters over here and I'll just plot the letters. So let's start with X. Or before we even start, let's put our intervals. So the number in between 0 and 2 would be 1. Then a number between 0 and 1 is 0.5. And a number between 1 and 2 is 1.5. So, let's start by looking at these numbers and trying to figure out where to place them. So, X, which is 0.946, is in between 0.5 and 1, and it is closer to 1 since is closer to 1 than it is to 0.5, because like if we multiply, sorry, no multiplication, 0.9, if we do 1 minus 0.946 is 0.946, and if we this number, the number we'll get is less than 0.946 minus let me just put brackets just for simplicity. 0.946 minus 0.5. So because of that, because this number is less than this number, this 0.946 will be closer to 1. So we'll just put an x here. We'll make it capitalized. X 0.502, that would be closer to 0.5 because we have the number 0.5 already in the tenths place, and then 0.2 that goes to the thousandths place, which will be very small. So that is closer to 0.5 than it is closer to 1. And keep in mind, it's still in between 0.5 and 1, since 0.9 was remove the hundredths and the thousandths place, and 0.9 is greater than 0.5 but less than 1, and same with y, the 0.502. So y would be right here, and then z, we see that's 1. So already we see 1, we know that this will be greater than 1. So, and 1.4. So we know that 5 is greater than 4. 4 is less than 5. So it would be around this range. Sorry, that was an accent. It would be in this range, and 0.42, that would be relatively close to 1.42 is relatively close to 1.5. So z would be right over here. And we have to order our containers from least to greatest. So container y is over here. Container, because, sorry, forgot to say y. Container y is the least because it's closer to 0, and container y is the least because it's on the left side of the number line. And remember our rule, the left is the least. And then container x is in the middle of y and z, so it would be the middle number. And container z is on the rightmost side, and therefore would be the greatest. So let's look at our answer choices and see which one best matches our order. Not this, not this, and not this. So our answer choice would be G. 30 is G, and I should use a green for that. G. So there we have it. Here 30 is G. Just to recap, 30 is G, 22 is 90.4, and number 2 is H. Once again, thank you so much for joining this live stream. I hope to see you next week, where we talk more about numbers and operations, and we'll go more into depth in this topic. This topic is really interesting. To see the past work, please look at our previous live streams. Those will be on our channel, and subscribe to our channel. That would really help support us. And yeah, thank you so much for tuning in to this live stream.